Hello everybody, I hope you are doing well. Welcome to this video. This is the video part number 1 from the test-driven development episode. If you didn't watch the video part number 0, you should watch it at first and then watch this video. Okay, what's on the agenda in this video? I'm going to implement a super easy example through test-driven development because I just want to demonstrate the basics of Google Test. And we will introduce to you some of C++11 features like a standard initializer list and a periodic template. Okay, in every session, at first check out the branch that belongs to that session. This is the video part number 1, and it means you should check out the branch session 1. Do you know how to do that? Okay, let me tell you. Open up the Visual Studio Code and then open our source directory, I mean TDD codes. Okay, in status bar there is a button for branch. Click on it and then check out the branch session 1. Okay, you're done. In the last video we have implemented the first CMake project, and I told you we are going to implement test cases in the session 1 CPP file. Okay, open up the session 1 CPP file. Back to our problem. Suppose your boss came to your office and gave you a new task, and it was implementing a C++ module to add up 2 numbers. It's very easy, isn't it? Alright, what do? Let me tell you. You just think a little about it and then you implement a class which is called math. And then you add a public function, add function. It takes 2 arguments, and finally you return a plus b. Okay, let me tell you something. This way of thinking is absolutely wrong in today's software development. Okay, let's implement it through test-driven development technique. The TDD technique says write a test, get it to pass, and clean up the design. That's all there is to test-driven development. These 3 simple steps embody a significant amount of sophistication. Okay, what should we do? Remove all of them. First of all, don't think about the implementation. Just think about how do you want to test it. Just think about the test cases. Let's implement the first test case. Include gtest header file from gtest directory and then test. What is this? This is a macro which is implemented in the gtest library to write test cases. This macro takes 2 parameters. The first one is the test suite name, and the second one is the test case name. The first parameter should name a collection of test cases, and the second parameter should describe what you are doing in the test case. Okay, let me name it. I name the first parameter to the math test, and the second one to add function should add up 2 integers. Imagine you have a class called math. Create an object. And imagine the math object has a function for adding up. Call that function, math.add, and give it 2 integers. And take the result Okay, take a look at this keyword. This is the automatic type deduction which was introduced in C++11. I will tell you more about it any minute now. And finally, we can validate the result through asset equal macro. This macro takes two arguments and checks their equality. We can give it a result to the first parameter and 6 for the second one. Okay, you did the first step of TDD steps. What was that? Write a test, and you have written a test. If you run this test, let me run our project. Okay, let me build it. It's failed. It doesn't compile, and it is a very important part of the first step. You should make sure that the test case that you have written, it will fail. It's very important. The error says the build directory doesn't exist. Okay, let me reconfigure it again and rebuild the project. Okay, it's failed. Let's get in the second step. It was pass the test. What should we do? Now you can think about the implementation. Just write a minimal code that passes the test. It is very important. Just write a minimal code. Okay, implement a class called math and implement a public function. And return A plus B. Okay, that's enough. Don't do anything. Remember, just write a minimal code that passes the test. Now we can run the test again. Rebuild and run without debugging. Okay, it's passed. You can see the results in the terminal. You see there are a couple of lines of report. At this point, this line says the test case is passed. Alright. The final step in TDD steps, it was clean up the design. The class is very simple, and also test case is very simple. You're almost done in those TDD steps that I've mentioned. Remember it. Write a test, get it to pass, and clean up the design. What should we do right now? We can start it again. We can write another test case and then try to pass it and finally clean the design. And because of that, these three steps are called TDD cycle. If you have noticed, there was a figure in this video cover. Let me show you. You see, this is the TDD cycle. It has three steps. The first one, write a test, watch it fail, and the second one, write just enough code to pass the test, and the third one, clean up the design. And then back to the first step. Okay, back to the code. Look at this. What do we need? Don't you think this module should also add up the real numbers? Yes, it should. Alright, let's implement the test. Test macro math test add function should add up two real numbers. Okay, same as the previous test. and give it 2 real numbers. Finally, validate the result. Then make sure the test is failed. Run test cases. Okay. Look at here. This line says the new test case that we have written is failed. Okay, the next step. Now write a minimal code to pass the test. It's very simple. We can turn this function to a template function. Type name t and then replace integer types with new template type. Okay, run test again. Alright, it's completed. All of the test cases now is passed. Alright, the final step in TDD cycle, refactor the code and test cases. Look at these two test cases. What do you see at line 14 and line 20? There is a code duplication. And you know that the first intention of object-oriented designing is remove the duplication. Let's remove it. We need a class to hold these lines of code. In TDD programming, we have a concept for this, which is called test fixture. In fact, the test fixture is a class that contains the common setup code and the data. Google Test also provides test fixture through test class. Okay, let's implement test fixture. Test fixture. You should inherit from test class. And now you can move the duplicate code here. Alright. Now you can integrate the test cases, the test fixture, by turning the test macro to test f macro. Test f macro takes 2 arguments, same as the test macro, but the first argument here is the test fixture. I should replace the first argument with test fixture. Alright, now run test cases. Okay, what happened here? I got it. We should move the math class to this point. Sorry. Run test cases again. Okay. What's wrong? Okay, this error says the math object is a private member. You can make it public. Now run test cases again. Okay, it's done. Okay, we can refactor it more. I can move this to this point, and also for this. Alright, you have done your task through TDD technique. Now you can give this module to your boss. As I said to you, let me give you an explanation about automatic type deduction in C++11 standard. Alright. Automatic type deduction is perhaps one of the more divisive features of modern C++. It's really a straightforward concept. Just let the compiler deduce the type of an object from its initializer. This is the basic form of auto. There is an auto keyword here, then object name or variable name, and then initializer. For instance, you can declare a variable in this way. As the type of 17 is integer, the type of a variable would be integer. Auto type deduction becomes much more useful when the initializer is more complex expression. For instance, a function call. In this example, the type of this variable would be same as the return type of this function, I mean begin. It would be a standard iterator. And this is another example. Okay, that was just a super basic introduction of automatic type deduction in C++11. To be honest, type deduction is one of the most important part of modern C++. It's really important to know how the language deduces the type for you. Okay, now I'm gonna play a video from Scott Mayers for you. It's a part of C++ 2014 Global Conference. It's about all sorts of C++ type deduction. He's really a great and famous author. If I remember correctly, his latest book was Effective Modern C++.
So from what I can tell, this is the landscape for type deduction in C++. And this is C++ 98. Normally we say there is one set of rules for type deduction in C++ 98. It's for templates, which I think is a little bit misleading because there's actually two sets of rules. One of the sets of rules is if you have a type that is a pointer or a reference that you're deducing for, and then we have a set of pass-by-value rules. There's really two rules. In C++11, they then introduced this notion of universal references, which technically are R-value references, but they're easier to understand as universal references, and there's special type deduction rules for universal references. That's a third set of type deduction rules. This is still inside templates. Then we decided to allow lambda functions to have implicitly deduced return types, and it turns out that the rules that lambdas use to deduce their return types is the same as the by-value rules for templates. So it's not a different set of rules, but it's a different application of an existing set of rules. C++11 also introduced decal type, which has a whole different set of rules we'll talk about briefly. Then C++11 also does lambda captures, which is where you capture variables. It turns out those types are also deduced. Those rules for type deduction are based on the rules for pointers and reference type deduction for templates, but they're not the same. So that line there simply indicates they're sort of derived from, but not in a is-a substitutability kind of way. It's just a derivation of that. So that's C++11. And of course, we've got auto, and when you are deducing types for auto objects, they're based on the template type deduction rules, but they're not identical to the template type deduction rules. In C++14, we also deduce types for auto parameters that are passed to generic lambdas. They use the same rules as template type deduction. So it's a new application of an existing set of rules. We have auto return type, which also is using the rules for template type deduction. We have one of my favorite phrases, decal type auto, which uses the decal type rules, not the auto rules. Don't be fooled. And then we have lambda init capture, and the lambda init capture rules are different from the C++11 lambda capture rules. So that should keep us busy for about 90 minutes, is my guess.
Okay, we are done. We're coming to the end of this video. Remember that you learn best when you get your hands dirty and follow along with the examples. I hope you enjoyed it. Thank you so much and have a nice one.